Good morning, students. Chapter 6, Electromagnetic Induction. Yes, in last lecture we have discussed about motional EMF. What is motional EMF? Okay, with the help of two examples. One, a wire PQ which is sliding between two parallel arms of U-shaped frame. And in another case, only one conductor PQ is moving in magnetic field. Now, what is LENZ law in this situation? What is LENZ law in this situation? See, and what is LENZ force? What is LENZ force? See here again, uniform magnetic field perpendicular to plane inside. Uniform magnetic field perpendicular to plane inside. A U-shaped frame like this. Okay. PQ wire is moved with uniform velocity in this direction. It is R. It is S. Yes or no? Yes. Length of this PQ wire is L. Length of this PQ wire is L. So here PQ wire, or we can say conductor, having length L is moving in magnetic field, is moving with velocity V in magnetic field V. Then this PQ wire behaves as cell, having EMF, E is equal to BVL, only magnitude. E is equal to BVL. Between these two ends of PQ wire, EMF is induced. Between PQ wire, EMF is induced. And yes, we know that. Remember again, velocity in this direction, magnetic field perpendicular inside, force acting on positive charge is towards P, while force acting on negative charge is towards Q. So yes, this P end becomes positive at potential, and this Q end becomes negative. Clear about this? This PQ wire behaves as cell, and we know that, conventional current is flowing from positive terminal of cell towards negative terminal of cell. So let current flowing in this closed circuit PSRQ, it is in this direction from positive terminal. Current I is flowing. Yes, current I is flowing. Clear about this? So let current is flowing from circuit. That is I. Now, how to find this current I? Let resistance of PQ wire. Is R. Let resistance of PQ wire is R. Yes, of PQ wire is R. We are neglecting resistance of this U-shaped frame. Okay, so that resistance of PQ wire is R. Current flowing from this PQ wire is I. Resistance of this PQ wire is R. And what is potential difference? What is EMF between two ends of P and Q wire? It is BVL. So yes, current from circuit current from circuit. Okay, it is I is equal to, it is E upon I. E it is BBL upon here it is I. BBL here it is upon I. So it is current. It is current. Clear about this? So yes, this equation of current. And it out. And yes, from this PQ wire current I is flowing. In PQ wire current I is flowing. In PQ wire current I is flowing. Clear? So now we can say this current carrying wire PQ is moving or is this current carrying wire is placed in uniform magnetic field. This current carrying wire is placed in uniform magnetic field. This current carrying wire is placed in uniform magnetic field. So here current carrying wire PQ is placed in magnetic field. So therefore, according to F is equal to IL cross B, force acting on wire. See, initially EMF is induced between two ends of P and Q wire. Due to that, current is flowing. That current is also flowing from this PQ wire. Current wire PQ is in magnetic field. So according to this equation, F is equal to IL cross P. Force is acting on wire. What is magnitude of this force? See, L. It is like this. Magnetic field perpendicular to inside. In last lecture we have discussed that its length and its velocity is perpendicular to magnetic field. Its length and its velocity is perpendicular to magnetic field. Then how to write? Yes, F is equal to IL cross P, force acting on wire. Its magnitude. How to write its magnitude? F is equal to this ILB sin 90. Why sin 90? This length is perpendicular to magnetic field. Means is equal to it is ILB. And acting in which direction? According to IL cross B. See here, IL in this direction. Yes or no? Current is going in this direction. B perpendicular inside. Thumb is in this direction. Yes or no? Yes. So yes, LENZ force. That force is acting in this direction. Again, F is equal to IL cross B. Current is flowing in upward direction. Magnetic field inside. So thumb is acting in this direction. So F is equal to ILB. Force is acting towards left. We have moved this wire PQ towards the right. We have displaced wire PQ towards the right, and this force is acting towards the left. Remember LENZ law? What is LENZ law? Yes, LENZ law is EMF is induced such that it produces current which opposes change in magnetic flux. Yes, we have displaced this wire in this direction, but in wire PQ EMF is induced such that current is produced such that LENZ force is acting in opposite direction. Clear about this? LENZ force is acting in opposite direction. Then yes, how to write? Yes, how to write? Okay, so see, here it is. Wire is displaced towards right. Yes or no? Wire is displaced towards right. Okay, wire is displaced towards right. Okay, wire is displaced towards right. Okay, but force on wire force on wire is acting towards left, which opposes its motion, okay, which opposes its cause. So therefore such force is called Lenz force. So here Lenz force F is equal to, here it is I L B. Now we know what is equation of I. Here it is BBL upon R. Here it is BBL upon R, and here it is L. So here it is B square L square V upon R. Here it is equation of Lenz force. And yes, this Lenz force is acting. Parallel to its velocity. In opposite direction to its velocity. Clear about this? So yes, to displace this wire towards right, we have to apply some force which balances this Lenz force. We have to apply some force which balances this Lenz force, because on wire Lenz force is acting on this direction which opposite its motion. So to move this wire in this direction with uniform velocity, we have to apply the same force in this direction. So resultant force becomes 0, and this wire will move with uniform velocity. Clear about this? So yes, it is case of Lenz force. Now I want to move this wire towards right. Yes or no? This force, Lenz force, opposes. But still I want to know, then I have to apply some external force. Then what is mechanical power? Mechanical power P is equal to, we know its equation, it is F into V. What is F? Lenz force. It is B square L square V upon R. Here it is V. So it is B square L square V square upon R. And if we displace this wire towards right, we know that area changes, magnetic flux changes. Due to changing flux, EMF is induced and current is flowing. So what is electrical power? Electrical power generated is, it is P is equal to, this is mechanical power PM. This electrical power PI is equal to, it is I square R. What is equation of I? Here it is I. BBL upon R. So here it is B square L square upon R square. And here is 1R. So R cut. So PI is equal to, it is PI is equal to, here it is B square L square upon R. See, observe these two equations. Mechanical power and electrical power. So yes, this mechanical power and this electrical power, they are same. If we neglect loss of energy due to friction, clear about this? So yes, it is one continuous case of motional EMF. What is Lenz force? Yes, Lenz force is acting in opposite direction of its cause. Okay? So yes, it is all about Lenz force. Now, one extra point, say here it is. We know that induced EMF, according to Faraday's law, E is equal to, it is minus delta phi upon delta t. or its magnitude only mode of E, it is delta phi upon delta T. Yes or no? Yes. What is equation of EMF according to chapter number 3, okay, Ohm's law? That is E is equal to, it is IR. What is equation of I? What is equation of I? It is delta Q upon delta T, and here it is R. R means we can say it is resistance. Yes, it is resistance. Clear about this? So now if we compare these two equations, it is equation of E, it is also equation of E. Then yes, we can write here it is delta Q upon delta T R is equal to delta phi upon delta T. Delta phi upon delta T. Delta T का delta T का. So delta Q is equal to delta phi upon R. Delta phi upon, it means what? It means what? EMF. It depends on d phi upon dt, rate of change of magnetic flux, and therefore current also depends on rate of change of magnetic flux, d phi upon dt. But charge induced, it depends on only change in magnetic flux. It does not depend on time. So yes, it is difference between induced EMF, induced current, and it is nothing but induced charge. It is nothing but induced charge. Clear? So yes, induced EMF and induced current, they both depend on rate of change of magnetic flux. Why this induced charge depends only on change in flux. So yes, it is difference between these three cases. Okay. So yes, with this one concept, that is motional EMF is done. Okay. So students, watch regular videos, make regular notes, and yes, appear for exam regularly. If you have any doubt, then contact me 7574858001, and yes, regularly you like, share and comment our videos. For today, this is it.